Hi everyone, this is Harshith of from ENH iSecure. In this presentation, we are going to discuss about custom connector in SailPoint IdentityIQ. So in this presentation, we will first go through basic introduction of custom connector, prerequisites for custom connector development, basic architecture of custom connector, how to build and design custom connector, and finally test the developed custom connector by executing some use cases. SailPoint IdentityIQ, being a vast product, has a flexible connectivity to manage applications. It includes many connectors through which it can connect to external systems to both read their data and to process provisioning requests. However, installations may need to create a custom connector to connect to an application for which IdentityIQ does not have a built-in connector. Sometimes we would need to develop custom connectors for existing built-in connectors if the features of those built-in connectors do not meet the business needs. So, depending upon the necessity, we do develop custom connector to connect with an external application. This custom connector can be developed to support both provisioning and aggregation activities. Before starting with the development of custom connector, these are the prerequisites the developer must qualify. The developer must be proficient enough in Java programming language. The developer must have experience in using IDEs such as Eclipse or NetBeans. The developer must possess minimum knowledge of SailPoint IdentityIQ, and the developer must have completed the IdentityIQ implementation training course, which projects a good overview about SailPoint IdentityIQ. Let us understand the high-level architecture of the custom connector and its working here. Any external application can be connected and managed by SailPoint IdentityIQ by custom connector. The custom connector acts as a barrier in between the external application and IdentityIQ. It allows the IdentityIQ to connect to the external application and perform read and write activities on the external application such as aggregation, provisioning, user lifecycle management, password management, access management, etc. Custom connector is built internally containing the logic to perform all these activities. Custom connector requires the dependency files, which are a XML file to merge with the connector registry and an XHTML file to define application UI for this connector. XML file contains custom connector details such as name, type, account type definitions, feature string, schema definitions, identity, display and instance attribute values, which is merged with the existing connector registry file in the IdentityIQ database, allowing IdentityIQ to create a new entry in the list of connectors. XHTML file contains the UI configuration of application page for this custom connector type. It contains the details of parameters which are required for custom connector to connect with an external application. These dependency files allow the custom connector to achieve the things what it is developed for. To build a custom connector, we should follow these three steps. Preparing a jar file, defining connector type and other details in connector registry, defining XHTML page. Let us look at each step in detail. Preparing jar file. The entire functionality of your custom connector is built using Java code. The custom connector uses the Open Connector framework provided by SailPoint in the Open Connector package, where there are a lot of methods provided for different types of operations. The custom logic which you want to implement using this custom connector shall be developed in specified methods. Once code development is completed, the custom connector code with all the classes must be compiled and packaged into a jar file. And the jar file must be placed in web.inf and lib folder in the IdentityIQ installation directory. Defining connector type in connector registry. Connector registry is an XML file present in IdentityIQ as a configuration object. This file contains the information about all the different connectors and their related details such as name, type, account type definition, feature string, schema definitions, identity, display and instance attribute values, provisioning policy forms for various operations on supporting object types, etc. Generally, this is done by creating and importing an XML file which modifies the existing connector registry. Here we will create an XML file consisting the details pertaining to our custom connector. Once we import this XML file into IdentityIQ, it will be merged with existing connector registry file in the IdentityIQ database, allowing IdentityIQ to create a new entry in the list of connectors. Alternatively, the connector registry could be manually edited through the debug page. Defining XHTML page. Usually some parameters are required to define the connection to the target resource as shown in the picture. Example, host, port, username, password, etc. To allow these parameters to be specified through the user interface for each application that uses this connector, an XHTML page must be written to define how the application configuration user interface will request and record these parameters. This file must be placed in applications directory which is found under define directory in the IdentityIQ installation folder. And this must be referenced in the application definitions XML as form path entry. If the application connection details will never be configured through IdentityIQ, but instead the connection parameters will be specified in the application XML object only and imported into the system, this XHTML page is strictly not required. However, without it, the connection parameters for the application cannot be modified through IdentityIQ's user interface. Let us understand the building process of custom connector in more detail in this section. When building a custom connector, we need to look into four important aspects comprising the design of custom connector. Defining the features of custom connector to be developed, defining the object types which the custom connector will support, defining the object schemas for the specified object types, defining the functionality to be performed by the custom connector. Let us look at each aspect in detail. The first step in connector design is determining the desired features for the connector. These are the list of available features. Authenticate. Will the connector support authenticating a user and a password combination against the resource? Create. Will the connector be able to create a resource object? Delete. Will the connector be able to delete a given resource object? Discover schema. Will the connector report schemas to IdentityIQ when queried, including both attribute names and types? Enable. Will the connector support enabling or disabling of a resource object? Get. Will the connector be able to read and return a map of specific resource object? Iterate. Will the connector return an iterator of resource objects? Permissions. Will the connector return permission attributes? Set password. Will the connector set the password of a resource object? Unlock. Will the connector be able to unlock a resource object? Update. Will the connector support updates of a resource objects? The application object also has a feature enumeration specified as feature string attribute of the application definition, which is used to control the functionality available through the connector. Some connector feature enumeration overlaps with, but it is not identical to the application feature enumeration. They correlate as shown in the table. For example, authenticate in connector feature enumeration refers to authenticate in application feature enumeration. Create, update, delete refers to provisioning in application feature enumeration. Defining supporting object types. The next design decision is to choose the object types the connector will support. Generally, these are account and group, though new object classes can be defined if required. Defining object schemas. For each of the object types to be supported, the final step is to define the object schemas and the data types of their attributes. The connector schema can support any of these data types: Boolean, date, int, long, permission, it is a SailPoint class with rights and targets, secret, it is an attribute that should not be logged or displayed to any end users, and finally string. The custom connector architecture uses the Open Connector framework provided by SailPoint in Open Connector package. This Open Connector package is provided with a lot of classes and interfaces inside it which can be used for custom connector development. All custom connectors must inherit from OpenConnector.AbstractConnector, which in turn implements the OpenConnector.Connector interface. The connector SDK, which includes the OpenConnector classes and the Java docs, is included in IdentityIQ zip file for any GA version. OpenConnector.AbstractConnector is an implementation of connector interfaces that all connectors should extend. And OpenConnector.Connector serves as a common interface for low-level communication to a resource. A connector serves as a common interface for low-level communication to a resource. The methods in this interface fits into one of the following categories. Connector capabilities. These provide information about what types of objects a connector can manage with and which features are supported for each object type. These are the only methods that do not require a fully configured connector. Example, get supported object types, get supported features, etc. Connector lifecycle. A connector is stateful in that it must be configured before it can be used and eventually closed. These methods define that lifecycle of connector. Example, configure, set object type, close, etc. Connector utilities. These methods test a connector. Example, test connection, discover schema, authenticate, etc. Object access. These methods allow you to create, update, and delete resource objects. Example, read, iterate, provision, etc. Custom connector can use abstract connector classes methods for implementing its own version logic, which will override the default behavior of the method. Here is a list of some of the abstract connectors provided functionality for each of these methods. Get supported object types. Should return a list of connectors supported object types. Returns an account. Test connection. Should determine if the resource is accessible. Example, connect to the application with login credentials pulled from the connector configuration. Discover schema. Should return the schema, attributes and data types of the currently selected object type. Authenticate. Should connect to the application with the credentials provided in the method call and attempt to authenticate to the application with that user ID and password. Iterate. Should return an iterator over the accounts or groups in the application, which can be a subset of accounts groups based on specialized filter. Close. Should perform any required steps to close the connection to the application. Create. Should create an account or group in the application given a native identifier and a list of attribute values. Delete. Should delete the object from the application based on the native identifier. Update. should update the values for the specified account or group matched by the native identifier. Enable should enable the object on the application based on native identifier. Disable should disable the object on the application based on native identifier. Set password should set the account password on the application given a native identifier, new password, optional current password, and expiration date. Using the Open Connector framework, developers must implement separate methods for different types of operations. These methods are automatically called by abstract connector class's provision method after it parses the provisioning plan passed to it. This simplifies development since it relieves the developer of the responsibility for parsing and interpreting the provisioning plan in the custom connector's code. The provision method can of course be overridden with custom logic in the connector, but it is usually preferable to leverage the built-in functionality. Finally, an application object must be created for the application. Use the IdentityIQ user interface to create the application. Select the configured custom connector as application type to tie it to the connector registry configuration and specifying any connection parameters through the configuration. Once the application is onboarded, we can perform all the configured functionalities in it and verify back the results within the targeted external application. Alternatively, application connector can be tested from the integration console, which can be opened by running IAQ integration command from the bin directory which is present in webinf directory which is present in the IdentityIQ's installation directory. This console can be used to test the various features of your connector, including aggregation and provisioning. Now our custom connector is ready to be used. Here we are going to implement a few use cases using the application configured from our custom connector. Here is a list of use cases which we are going to implement. Account aggregation, group aggregation, create account, update account, disable account, delete account, and enable account. Let us look at each operation in detail. These are the list of methods triggered in the jar file when executing different use cases using custom connector. When we execute account aggregation task in the SailPoint, getObjectsMap for type accounts will be invoked. When we execute group aggregation task in SailPoint, getObjectsMap for type groups will be invoked. When we perform create account operation in application using SailPoint, create method is invoked and this method will handle account creation logic in application. When we perform account update operation in application using SailPoint, update method is invoked and this method will handle the logic for updating the account in the application. When we perform disable account operation in application using SailPoint, disable method is invoked and this method will handle the logic for disabling the account in the application. When we perform delete account operation in the application using SailPoint, delete method is invoked and this method will handle the logic for deleting the account in the application. When we perform enable account operation in application using SailPoint, enable method is invoked and this method will handle the logic for enabling the account in the application. Prior to start with any of the earlier specified operations, we have to perform test connection operation. As shown in the picture, we would need the following connection parameters in order to connect with the Active Directory using our custom connector. Once you submit all the required connection parameters and click on test connection, it would try to connect to the Active Directory domain within the provided domain IP address and return the result whether connection is successfully created or failed. Starting with the use cases, we would start with account aggregation. This operation would connect to the configured external application and get the list of account resource objects as response from the Active Directory. These resource objects are supplied to the connector, uses the information from resource object and creates accounts in IdentityIQ. The next operation is group aggregation. This operation would connect to the configured external application and get the list of group resource objects as response from the Active Directory. These resource objects are supplied to the connector, uses information from the resource object and creates groups in IdentityIQ. Next operation is create account. For this operation, we use a delimited file-based application as our truth source. Once a new entry gets added in that file, a new identity will be created from the aggregation task. Upon running the refresh identity cube task, a configured lifecycle joiner event will be triggered to handle the account creation process in the target application using provisioning plan. Custom connector would receive this plan and perform the create operation in the external application as specified in the logic of create method. The end result will be a new account is created for this identity in application in IdentityIQ and a new user is being provisioned into external application. The next operation is update account. Here, when the department attribute in truth source gets updated, a identity will be updated with the new value from the aggregation task. Upon running the refresh identity cube task, a configured lifecycle mover event will be triggered to handle account updating process in target application using provisioning plan. Custom connector would receive this provisioning plan and perform update operation in the external application as specified in the logic of update method. End result will be the account is updated with the new department value in the external application. The next operation is disable account. Here we will receive the status update to disable the account from delimited file truth source. This gets updated on identity from the aggregation task. Upon running the refresh identity cube task, a configured lifecycle disable event will be triggered to handle account disabling process in the target application using provisioning plan. Custom connector would receive this plan and perform the disable operation in the external application as specified in the logic of disable method. The end result will be the account is disabled in the external application. The next operation is delete account. Here we will receive the delete trigger from the delimited file truth source. This gets updated on identity from the aggregation task. Upon running the refresh identity cube task, a configured lifecycle delete event will be triggered to handle the account deletion process in the target application using provisioning plan. Custom connector would receive this plan and perform the delete operation in the external application as specified in the logic of delete method. The end result will be the account is deleted from the external application. The next operation is enable account. This is considered as a rehire scenario. Here we will receive the status update to enable the account from delimited file truth source. This gets updated on identity from the aggregation task. Upon running the refresh identity cube task, a configured lifecycle enable event will be triggered to handle the account enabling process in target application using provisioning plan. Custom connector would receive this plan and perform the enable operation in the external application as specified in the logic of enable method. The end result will be the account is enabled in the external application. That is the end of the use cases which we have performed on the custom connector. A well-versed technical white paper is provided by SailPoint Compass about custom connector which is available and the links are provided on the screen. Please subscribe to ENH across various social media platforms for further updates.